Hello guys and welcome to another video. Okay, right guys, today's video actually we will be looking at system of linear equations, and I will be talking you through obviously like one example but two different methods on how to solve a like pair of like system of like equations, a pair of equations or more. Right, guys. Okay, right, guys. Before we start here, obviously, if you're new to my channel, actually, my name's Abdallah, actually, and I'm a private maths tutor and a qualified maths teacher. Okay, recently this year, actually, from the 1st of January 2020, um, and I make videos for all levels of maths from Key Stage 2 right up until A level maths, and also like university level maths as well. Okay, right, guys. Okay, so this is obviously systems of like linear equations. So this is going to be aimed at probably like undergraduate students at university, or even further maths. Obviously, like A2 students that might have like come across this, and AS students. Right, guys, the system of equations actually. If we look here, guys, actually, right, a simple linear equation actually is just literally like essentially like this actually. So I can have like two variables, three variables, four variables, and etc. etc. Okay, now this one actually, this is what we used to call actually like a simultaneous equation actually. So you would have actually seen this here when you studied like GCSE maths. So it's like obviously in year 11. And obviously it can be solved actually, obviously by the elimination method or by the substitution method actually, or obviously by like rearranging obviously like one to sub into the other. Okay, which is essentially the substitution method. Okay, but sometimes the equations obviously will not be very nice to, or sometimes it would just be difficult to implement this like practically, because you might have some really awkward numbers, or just have some like hard examples. Now, guys, if we look here, I can write this here as like a system like equation. So I can write this matrix here as this. I've got ax plus equals b. So xy, so that's my like variable here. So that's my vector like x. Okay, so it should be underlined actually. So ax is equal to b. Okay. So I want to work out, obviously what my x vectors, so what x and y are. Now, one way to do actually is that I can rearrange this here to make x the subject actually, so I can multiply both sides by a inverse, okay, which I'll come on to obviously on my second example actually, that we can start see below. Okay, but firstly, we're going to start off actually with like this example here. Now, if we look here, guys, okay, so this is matrix A times X is equal to B. Okay, so I've let A is equal to this, 2, 3, 10, and 1. Okay, I've let A1 equal this, and A2 equals this actually. So this is what I call Cramer's Rule. So A1, so what I've done is I've replaced the first entry here actually with the first entry here. Okay, and then I've worked out, the determinant for that, okay, for A1. And then for A2, I've replaced 3 and 3 with 7 and 10. And I've worked out, the determinant for each one of those, like, cases. Okay, so I've worked out determinant of A, A1, and A2. Now, by doing this process, guys, by replacing, actually, we're actually solving and actually finding solutions for x and y. Okay, so the process is that to work out x here is the determinant of a1 over det a, y is equal to determinant of a2 over a, and then that would be my solution actually, guys. Right, guys, if you remember, obviously, from the previous videos just here, obviously, when we looked at, like, determinants and, like, inverses of, like, matrices, determinant is worked out by doing that number times this number, so it's 2 times 3 minus 3 times 10, actually, okay? So it's these two diagonal minus these two multiplied diagonal, okay? And that's how I work, actually. So I get 2 times 3 is going to be 6 minus that, it'll give me minus 24. Okay, so that's how I work out determinant of A. And then A1, it'll be 21 minus 30, which is minus 9. A2 would be 20 minus 70. And that's how I'd work out, my determinants of A1 and A2. And my solutions are just simply x equals minus 9 over 20 minus 24, which is 3 over 8. And then A2 is equal to minus 25 over minus 12, okay, which is equal to 25 over 12. So that would be my solution for that. So that's known as the Cramer's Rule, guys, okay, so that's actually quite like a nice method actually, and it's used for like 3x3 systems, 4x4, and it's, yeah, 5x5 actually, and so on and so forth. Right, guys, just very quickly now, actually, just obviously come, yeah, the second method, so the inverse. Right, to work out x from what I said before, actually, is I would multiply both sides by a minus 1. Okay, so I have to work out the inverse of a. So the inverse of a, actually, okay, because that's how I get the x vector on its own, actually. So this is like another method, guys. So it's the inverse method. Okay, to get x is b times a inverse. Now, from before, obviously, A inverse is 1 over delta A times the adjoint matrix of A, which is the cofactor of A transpose, which is plus, minus, minus, plus here. So we're going to use actually and transpose it. So we get, yeah, so the adjoint matrix here, I believe, is 3 minus 3 minus 10 and 2. Okay, so it's just swapped those two around and then made those negative. Okay. And then the determinant we got as minus 1 over 24. So we worked that out actually from part A. Okay, that A is equal to minus 24. There it is. Okay, and then all we did now, guys, is all we did was do x is equal to b times a inverse, or a inverse times b. Either way, it's fine actually. So minus 1 over 24 times 710, which is obviously vector b, times by 3 minus 3 minus 10 and 2. Okay, so my solutions would be, so obviously multiplying that actually, yeah. So multiplying that, so 7 times 3, 10 times minus 3 gives me minus 9. 7 times minus 10 plus 10 times 2 will give me minus 50. So x is equal to minus 1 over 24 actually, times by this vector. I get this, and then it simplifies my answer to 3 over 8 for x, and then y is equal to 25 over 12. So that is my solution to that, okay, using two different methods. Okay, so I hope that was actually clear, guys. Okay, so that's the Cramer's rule, and that's the inverse rule. Okay, so I hope that was actually clear, guys, and I hope it was informative. Thank you for watching. Actually, yeah, please do obviously drop the video a like, subscribe if you're new, and then enable notifications. Okay, and I will see you soon, guys. Thank you for watching. Stay safe. Bye.